Okay, guys, as we take a look at our warm-ups, if you're watching this on video, 5th and 6th period, if you'll have the sub, or if one of my students will hit pause on the video as the rest of you diligently work on the warm-ups today. These warm-ups are a great review of things that you will see on your test Tuesday. Okay? So, if you're in 5th or 6th period, please hit pause on the video now. And when everybody's done with the warm-ups, please press play. Alright. Hopefully you're done with the warm-ups. And now we'll look at examples 1 through 4. Okay, so number 1, we could find the missing arc here is 20 degrees because all the way around the entire circle is how many degrees, class?
360.
360. So we would add up these three, subtract from 360, and we would find that the missing arc was 20. So this angle formed by the two secants is 1/2 the difference of the intercepted arcs. So it's 120 minus 20. And so we'd get that the angle would be 50 degrees. Any questions? All right, number 2. They didn't give us enough angle measurements, you may have thought. But with knowing that this was 60 and this is x, and all the way around is 360, then for this angle here, it would leave 360 minus this 60 minus this x. So do you see where we get that this arc has a value of 300 minus x? So this angle of 45 degrees is equal to 1/2 the difference of the larger arc minus the smaller arc. So 300 minus x is the larger arc, minus x is the smaller arcs. So we get, this would simplify to 300 minus 2x, which we can actually take half of. You could also multiply both sides by 2 to get rid of that 1/2. And either way you do it, you should have found that x was 105. Adam, did you get that?
Yes.
Adam, you don't even have paper out.
Yeah.
Okay. Number 3. This is segments formed by intersecting chords. So we know that the product of the segment parts of one segment is equal to the product of the segment parts of the other. And we should get x equals 2. Did you get x equals 2? Yes. All right. So number 4, this is a segments formed by a secant and a tangent. And when we have it on the outside, we think the outside part times the whole is equal to the outside times the whole. All right. So in this case, we do the outside part, which is 6, times the whole part, 6 plus x, is equal to the outside part, 9, times the whole part, 9. So this ends up being 9 squared, which is 81. And this, when we distribute, is 36 plus 6x, subtract 36, divide by 6, and we get x is 7.5. How did you do?
Matt, are you okay?
You did well?
Are you okay?
Okay. Let's move on then. Okay, this homework answer key had all the problems, even though I didn't give you all the problems on it. So look through, see what you think.
Yay.
So for number 2, it should have been 6 times 4 equals 3 times x, and you should have found that x is 8. Any questions about number 2? Number 4, you get 4 times x and 5 times 18, so x is 22.5. Okay? Number 6, 3 times x and 5 times 15, and we should have gotten 25. Okay, now on these two, 4 and 6, let's take a look at this. It is outside times the whole, and they did a strange thing here. They gave us the whole part is x. Now in our examples yesterday, I never gave you the whole, did I?
Nope.
I gave you both the parts, and you had to add them up to find the whole. But do you see how here they give us the whole, so we don't have to add anything to it? Same thing here. They gave us the whole was x, so we don't have to add the 3 to it. That is actually the entire segment. Okay, so take a look at those. If you need to make corrections, please do so. All right, are we ready to roll? Okay, let's take a look at the next few. Number 8, outside times whole, x squared is equal to outside times whole. Well, the whole is 16 plus 2, or 18. And so here we get x squared equals 36, so x is just the positive 6. Now, when we solved x squared equals 36, if it were not in context of this problem, we would actually get x equals plus or minus 6. But when we're talking about segment lengths, are lengths ever negative? No. So in context of this problem, it is just positive 6. Any questions? Let's move on. Okay, did we skip number 10?
Yes.
Okay, so number 11, it's the product of the segment parts. Number 12, same thing. So take a look at these in second period, see if you have any questions for me. Hopefully if you do, they'll be the same questions that 5th and 6th might have. Sure. Okay, so we're going to do outside times the whole. So it's going to be 5 times the x, because x is the whole, is equal to the outside part times the whole. So 6 times the whole, which is 10. So we get 5x equals 60, divide by 5, and x is 12. Yes, on number 15, we swapped them, didn't we? That's what we talked about in class, because you can't do number 15 as written. So let's go ahead and swap those. And so this was our 10, and this is our x. So we would do here, outside times the whole is equal to outside times the whole. So we get 100 plus 10x is equal to 128, is that correct? And so we would subtract 100, and so we get 10x equals 28, so x equals 2.8. Okay? Which one? When they give you the whole? Yeah. Yeah. Okay, let's move on. All right, check out 17 and 18. Number 18, sure. These are marked equivalent. So if this is x, this is also x. So when I set this up, it's going to be outside times the whole, so 8 times 8 on that segment. And then this one is going to be outside, which is x, times the whole. Well, here's an x and here's an x, so the whole thing is 2x. So here we have x times 2x. Well, x times x is going to be x squared, and this is understood 1 here, so 1 times 2 is 2. So this becomes 2x squared. Now, when we solve an x squared, the first thing we do is get rid of our coefficient. The inverse operation of multiplication is division, so we'll divide both sides by 2. So we have 32 equals x squared. We take the square root of both sides, and normally I would put plus or minus, but since I'm dealing with links, I'm just looking at the positive, so I left that off. And the square root of 32, well, 32 breaks down into 16 times 2. So this is a nice reminder of how to simplify radicals. 4 roots of 2 is equivalent to x. And if you change that to a decimal, you would have gotten 5.7. And since I didn't tell you you had to leave it as a simplified radical, I could have taken either. Okay, does that make sense for 17 and 18? Yes, you had to do number 20 and 25. I left 25 written off the board for at the beginning of second period, so if you didn't do it, I won't count off, but it was a good problem. All right, here's number 20. So we do multiply our segment parts, and then we get 6x squared equals 54. Divide by 6, we get x squared equals 9. Take the square root, and we get x equals 3, and once again, we don't have the positive and negative here because we're dealing with links. All right. Apparently, I didn't copy all of this, so let's walk through this. This tells us there is a arch over a doorway that is an arc that is 160 centimeters wide, and 50 centimeters high. You are curious about the size of the entire circle containing the arc. By drawing and labeling the circle passing through the arc as shown in the diagram, you can use the following steps to find the radius of the circle. So the first thing they ask us to do is find AB. All right, so what was your approach on AB? Well, AB is given to us right here. It is 50 centimeters. Okay, so we know that this has a length of 50 centimeters because it's marked right here in our picture, and we have the words for it there. Okay, part B. Ask us to find the length of AC. Whoops, length. Length has no bar over it. And AD. Well, we see that this chord here has been is perpendicular to the radius. Therefore, that chord is bisected, right? Yeah. So if the entire chord is 160 centimeters, then when it gets bisected, each of those parts would be 80 centimeters. Does that make sense? So let's put an 80 up here. Oh, I put AC and AD. Thank you. Equals 80. All right, part C. Use A, B, A, C, and AD to find EA. EA. So now we want this whole length. Whoo, how would we do that? Well, we know that 80 times 80 would have to equal 50 times EA. Do you guys see that? Because E is down here. I cut it off on my picture, but E is down here. So this is what we studied. So we get 6,400 equals 50 times EA. And when we divide by 50, we get what? 128. Okay? Now we're asked to find EB. So EB is going to be the sum of these two. So 128 plus 50 is 178. And then E, find the length of the radius. What do we do?
You use, I don't know.
Divide by 2, right? Divide EB by 2.
Divide EB by 2. And so we get the radius is 89 centimeters. Okay, any questions about number 25? Okay. Our lesson today is about arc length. So let's. Okay. So today's notes are on arc length, and arc length is defined based on circumference. So let's take a look at what we already know about circumference. Circumference is the distance around the circle, and we have two formulas for that. Circumference equals 2 pi r, or pi d. Now, arc length is where we're just looking at a portion of that circumference. So instead of all the way around the circle, we're just looking at the portion of the circle with regards to arc BC. So how would we find that? Since we're just looking at part of, or a portion of the circumference, you would do the measure for the central angle that forms that arc over 360 times 2 pi r. And that gives us arc length. And that's what we would do every time. So here's an example. Example 1. Here's our circle, and our central angle is 62 degrees. The radius of this circle is 10 centimeters. And I'm asking you to find the arc length of arc PQ. So what we would do is we would do degrees over 360, which in this case would be 62 over 360, times 2 pi r, and the radius in this example is 10 centimeters. Now we have two ways we can give our answer. We can give our answer in either exact form, which I already have the answers up here, or approximate form. To find exact, you're going to leave your answer in terms of pi, and that's what exact would mean in this case, in terms of pi. So we'll have pi in our answer. But if we're going to use our calculator to do these calculations, we would not punch pi into the calculator. So we would just do 62 divided by 360 times 2 times 10, and that would give us 31 ninths. Now this is in terms of pi, and since we left pi out, we have to add it back in here. So the exact answer would be 31, I think I said 32 a moment ago, 31 ninths pi centimeters. Now, if you want the decimal approximation, you have the 31 ninths in your calculator already. Just put times pi, and you may have to hit the double arrow button to have it turn it into a decimal for you, which is approximately 10.8 centimeters. Okay? And that is how you find arc length. Pretty simple. Now, the only other way I could give you a problem like this is if we started off with arc length and we found something else. So here is example 2. On this example, for circle Q, we see it has a radius of 12.3 feet. And I'm telling you that the arc length of arc RS is about 38 feet. And you're to find the measure of arc RS. Well, the measure of an arc is the same as the central angle. So, if we look at our formula, which is degrees over 360 times pi r squared, not pi r squared, just 2 pi r, is equal to our arc length. Let's plug in the information we have here. We don't know the degrees. That's what we're trying to find. We do know that the radius has a length of 12.3 feet. And we do know that the arc length is approximately 38 feet. And so we're just solving for x. So to solve this, you might first want to multiply both sides by 360. And so we get x times the 2 pi 12.3 is equal to 38 times 36. And then we would divide by the 2 pi times 12.3, divide by, and make sure when you do your division that you're dividing by all of this. So you would want to put it in parentheses. And when we do this, we should get the measure of that central angle is approximately 177 degrees. So if the measure of the central angle is 177 degrees, then the measure of that arc is also 177 degrees. So the measure of arc RS is 177 degrees. Now, your homework is out of the textbook. You should be able to finish it in class if you work diligently, which will be a bonus since we don't have IF today. Those of you will not be able to use IF to do your homework. So let's take a look. Your homework is out of your book. It's on page 411. You're doing problems numbers 10, 19 through 25, 29, 33, and 39, parts A through C. And I will see you guys tomorrow to answer questions.